Okay, so our first objective is going to be able to use a graph to evaluate functions, not using the equation and putting the input in and finding out what the output is, but instead using the graph to do it. Well, you really have already been exposed to this on that exit slip. So that exit slip hasn't been going so well for you. Maybe after this it will go a little bit better. That was the one you just got back, I believe, today again now, the purple. Okay, so we're doing checkout problem number 3, and we are supposed to use the graph to find f of x equals 3. So remember, f of x is the same as what? As y. So if f of x is the same as y, they're really saying then that you're supposed to use the graph to find when y is 3. So when is y equal to 3? That would mean we got to find the x value. So how are we going to do that from the graph? How are we going to find what x is equal to when y is equal to 3? Carson?
Go to 3 on the y-axis.
1, 2, 3.
And look for where the line crosses the x.
And move until you land on the graph itself. Because the coordinate plane is not really called a graph. We call it that, kind of loosely. The coordinate plane is what we graph on. The graph here is actually a line, isn't it? So we have to find anything anywhere on that graph where the y value is 3, and by determining what the x value is, we'll answer the question. So what's the x value of that ordered pair? It's also 3. Okay. So when y equals 3, x happens to equal 3 also. Okay, now it says we're going to check our answer. So we are going to take both our x value and our y value, and we're going to substitute them into our function. So f of x is 3. X is 3 in this one also. Well, 3 is 3. What's a third of 3? 1. 3 is still 3. And 1 plus 2 is 3. So it checks out. The y value that we were given when we found our x value, both of them make the equation true, so that means it should be a correct answer. Okay, well now it says, I have some additional here. I say, let's use the graph to find the value of x when f of x equals 1. So go ahead and do that. Find the value of, and do a check problem. Make sure it checks out. Get and check. I'm not the check. Don't check me. Check yours. Is yours check? It appears that 1 equals, this would be -1 this time. So 1 equals -1 plus 2 is 1. My x equals -3 checks. Anybody get something else to check out? That isn't x equals -3. So where does that -3 come from? From the graph. We follow to the graph, we go on the graph, we find where y is equal to 1. Follow to the graph and plot any points that have a y value of 1. And we would have whatever the x value of that ordered pair is should take care of it for us. Okay? So I want us to do, let's just do a little add-on here, okay? Let's do this. Let's practice another one. Let's do find f of 6. Find f of 6. Okay, see if you think you know what you gotta do to do that. Okay, who thinks they know what f of 6 is? This is our f of 6 value. Come on. No confidence? Carson?
4.
4. So Carson says f of 6 equals 4. Anybody else get that? You? Okay. How do we get it? How do we get it, Carter?
Multiply 6 by 1/3, and then you get 2 for that, so you add 2 plus 2.
Oh, so you put it into the function, into the equation itself and found it, okay? So he said, so you took 1/3 times 6. Why did you take 1/3 times 6?
Because f of x is, or
The 6 is in the place of the x value, isn't it? F of x is how we say it, so if it's f of x, instead of x, there's a 6 there, that means, this really means that x equals 6. So either you can do like Carter did, you can put 6 into the function, and you'd multiply by the 6 by 1/3. He said you get 2 when you do that. Add 2 to it, and you would have your value of 4, and that 4 is really the what? The y value. So we now know that the y value is 4. Okay, what's another way we can do that? What did you do, Carson, since you answered it?
Looked at the graph, since 6 is in the x value, you go to 6 on the x axis, and then look for the y value.
It's right there. 6, 1, 2, 3, 4, or 6, 4. Okay? So being able to use the graph to evaluate functions. Any questions? It's really important that we understand this notation too. If you're asked to find f of 6, you better understand what they're asking you to find. So no questions. Okay, then let's go to the backside and do check it out problem number 4, our other objective. Our other objective is to use a graph to model a situation, a real world situation, and then use the graph to make estimates or predictions, not use the function itself, okay? So what's going on in this one? Somebody tell me what's happening. Check it out problem number 4. We're going to take a couple of moments to read it. In your book on page 182, I think. Okay. 189?
Yeah.
That must be going backwards. 189? So, anybody give me just a brief rundown of what the situation is? Not what they're asking us to do, what's the situation? What's going on in this problem? I don't want to hear from Carter and Carson again, sorry. I want to hear from somebody else. Alex?
How many miles the lava moving after 5.5 hours?
Okay, that's the question being asked. So in other words, there's lava moving, and it's apparently being timed. Okay, Abigail?
The fastest recorded Hawaiian lava flow moved at an average of speed of 6 miles per hour.
Okay, so we have this average, the lava flow coming out of this volcano is going at about a rate of 6 miles per hour. So what's the independent variable in this situation? Carter?
hours recorded.
Okay, the number of hours recorded. How long was the lava flowing? Okay, not the 6. The 6 is what? And that's not even the dependent. What is the 6?
It's not gonna work.
It's like a set number saying this is how fast it's moving. That doesn't change. The independent variable can change. We get to say, here's what we want X to be. We can't change how fast that lava is moving. It's moving at a rate, an average rate of 6 miles per hour. So then what's the dependent variable? Because we're having a lot of trouble identifying these independent and dependent variables. What's the dependent in this situation? What's going to change based on what happens with the independent variable, in other words?
How far?
Abigail?
How many miles it travels?
How many miles it travels, yeah. And we don't want to just say how far, but maybe Connor was going to finish that. How far it travels in miles. We have to talk about time in how is it being measured, and we have to talk about distance and how it's being measured. Well, the graph already takes care of all that for you. All you have to do is look at the graph. Independent is on the x-axis. Dependent is always on the y-axis. Here's our function right here, y equals 6x. The x can change, okay? Do they give us any sort of a domain? Do they say anything? What do you think the domain is in this problem then? Would this be a discrete graph or a continuous?
Discrete.
Discrete. Okay, so in other words, the lava can only flow for set amounts of time. It's going to flow for 1 hour, exactly 1 hour. I mean, it's going to flow continuously, isn't it? Over time, the distance covered. This is going to be a continuous graph. So let's think about what our domain could be. Our domain is x. So tell me something about the restriction on x. What can't x be? Because can we say all real numbers?
No.
No, because there's some restriction. What restriction would there be on x? Amber?
You can have like -1.
You can't have negative time. So if you can't have negative time, what's our domain going to be? Positive or 0. So how would we write that? Can we list all of the positive numbers? Is that even possible? Can we start at 0 and start listing them all? No. So how are we going to do it? Yeah. That takes care of 0. That takes care of all the positive numbers, doesn't it? Okay. Well, what do you think the range is going to be then? All real numbers? So x is less, or well, somebody said, try to convince you to change it to y. Y is less than or equal to 0. What's y? What's the y value representing? What's the dependent variable representing? Miles. Okay. So tell me something about the numbers less than 0. They're negative. Okay. Is there such a thing as negative mileage? So I'm thinking that that's not what our range is. Same, but we're just going to change the variable. It's going to be y is greater than. So if no time has gone by, it's going to have covered 0 miles. But if time has gone by, it's going to cover a positive number of miles, isn't it? So this is a continuous graph. So we're going to have to, we can't have it, it's not discrete. So there's not going to be set x values. We're going to pick them. So I want, just because the graph seems to be set up to go through 6 on the x-axis, we're going to do it. We're going to do 1, 2, 3, 0, 1, 2, 3, 4, 5, and 6. We will put the domain value into the function rule, get our y value, and write it as an ordered pair. Okay, complete that table. Showing substitution, using the function rule, getting your output, writing the ordered pair that has both the input and the output. And what just seems to be going on here? As x goes up by 1, y is
Going up by 6.
going up by 6, isn't that something? Okay. Go plot those ordered pairs on your graph now, please. And I will send some rulers back for you to draw a continuous graph. And I'm pretty convinced that since the y's and the x's are changing at a constant rate, it is going to be a straight line. That's back to rulers, please. Plot those 7 ordered pairs on the graph. Use the ruler as a straight edge. And when you're plotting those ordered pairs on the graph, you're going to have to make sure that you're trying to be as accurate as possible, because not all the points are going to land on an intersection of grid lines like 0, 0 does. Don't throw it away. Everybody get one? Everybody get your change? And remember, your graph should actually also,
Yeah, like,
your graph should actually represent your domain and range. So what will our graph actually be? Will it be a straight line? It's going to be straight, all right, but it's not going to be a line. What's it going to be? A ray. It starts at 0 and it goes through all of the points, and of course it goes on forever. So we show that the domain, remember, the domain is x is greater than or equal to 0, y is greater than or equal to 0. So we have to make good decisions about what do we do with those points on our graph. And then now we're ready to answer that question that they asked us. It said, use the graph. Is that using the equation? No, don't use the equation. It says use the graph to estimate. So what are you going to do? It's kind of like saying f of 5.5, that's what we're really looking for. F of 5.5, that's what we're looking for. So go on the graph and find f of 5.5. And estimate. We should not all necessarily have exactly the same answer. Somebody might, either have a bad graph or their graph that just looks a tiny bit different than somebody else's. We should all be in the same general area. So who wants to give me what this is approximately equal to, because we are estimating? Katarina? 34, okay. Anybody else have a different estimate? What do you have, Connor?
33.
33, okay. Anybody else's graph gives them a different estimate? Abigail?
32.
About 32, okay. Anybody else's graph gives them a different estimate yet? So what do we do to get this estimate? So here's what I want you to do right on your graph. No, we're not plugging it in. That's not what we're doing. We're going to 5.5. And we're going to follow it up to the graph. We're going to have to plot ourselves a point there, and we're going to follow it over to the y-axis, and we're going to say, what is my estimate? That's how we use the graph. We don't put it into the function. The function can be used to get an idea if we have a decent graph, maybe a good estimate. Yes, Carter?
So like when we're showing our work on this stuff later on, do you want us to like plot out the doc, like to check our answer that you did?
When you're estimating,
Yeah, like.
Nope, when you're estimating, you can just do this.
Yeah, you want this to.
Yeah. Show that, because then that's, when you give an estimate, and your estimate is different than somebody else's, I'm gonna be like, but this is what their graph supports, so I can't say theirs is wrong. If that's what your graph supports, then that's what it is. It should be somewhere in this vicinity, somewhere between 32 and 34. Because what is it exactly?
Yeah, it's 30.
It's 33 because 5.5 is halfway between 5 and 6. 33 is halfway between 30 and 36. So do we have good estimates? Yes, we do. Okay, that's how we do it. Okay, questions? Okay, then let's get busy with our next thing that we need to be doing. Okay? Could you guys stop playing?